So in figure 5, to what depth would the ship sink if it was floating in ethanol instead of water? Well, we'll have to look at figure 5 in a moment, but the main thing to understand is that if it is floating, then the forces are balanced, and those forces I'm referring to there are upthrust and weight. So we've got the upthrust of the, in this case, acting on the boat from the ethanol, and then we've got down here we've got the weight, which is going to be equal to mg. Now the upthrust is going to be equal to we did a lesson on this about floating a while ago, but when I say m here, I mean mb. So we could say of the cylinder, hang on a second, ship, let's say ms. Okay, so the mass of the ship multiplied by gravity. The upthrust is actually caused by the water trying to fall, so that would be the mass of actually ethanol this time. The mass of the ethanol trying to fall multiplied by gravity. And what we're saying is that the mass of the ship multiplied by gravity is going to equal to the mass of ethanol multiplied by gravity. Now so let's just simplify it at this. Hang on a second. Yes. I just need to think about this for a moment. Yeah, I think pretty sure that's right. Yeah, I have to have to go through and see if this works. So, what do I mean by the mass of the ethanol, though? What mass are we talking about? Well, it's going to be the mass. Sorry, say again. Well, you're going to use the density to work it out, but the specific mass I'm talking about is the mass of the ethanol that has been displaced. So it's asking us what depth. So in other words, it's underwater, isn't it? It's under the ethanol, and we want to know what depth has been displaced there. Okay, so that would be they use h, so we could say height above, whatever amount, whatever you want to think about it there. So so we're going to it might be better to actually turn that into a square. There you go. And let's just color it in as well, so it's just a bit more visible. And we'll send, yeah, that's good. Okay, so now we think, well, that bottom part of the boat, of the ship, is that volume of the ship is equal to the volume of the water, of the ethanol that has been displaced. Let's just look at figure 5 for a moment to see what information we've got on that. Where's figure 5? That'll be this one. Okay, it doesn't really give you much information there, but it does tell you here that the density of seawater is that. We should hopefully, okay, here we go. The area of the bottom of the ship, which is 40 times 500. Yeah, so that must be the area of the bottom of the ship, so 40. And we must have worked that out by a previous point, okay? So the area of the bottom of the ship is 40 times 500. Okay, so we've got, so this bottom part here, the area at the bottom is equal to 40 times 500. And then the volume is going to be equal to the area multiplied by the height. Does that make sense? This is it. When I say the volume, I mean the volume of the ethanol that has been displaced, or the volume of the volume of the ship that is immersed in the ethanol. Happy with that? So as the ship goes down, then it pushes the ethanol up. The ethanol is trying to fall, and the ship is trying to fall. And when the ship falls, it pushes the ethanol up. When the ethanol falls, it pushes the ship up. Those two forces of the falling ethanol and the falling ship are balancing one another out. So the falling ethanol can be described as the ethanol that would like to fall. It's basically the upthrust that's forming the upthrust. So okay, So now we can see this mass of the ethanol. The mass of the ethanol is going to be equal to, well, density is kilograms per volume. So if it's going to, so if we do the mass per volume, which is the density multiplied by the volume, then we're going to get the mass of the ethanol. So the density of the ethanol multiplied by the volume of the ethanol that has been displaced is going to be equal to the mass of the ethanol. And that's going to be equal to 920 multiplied by, let's work out what A is now. 40 times 500 is, so the area is 20,000. I believe that was meters squared they gave it in, I presume. Let's just check. Yeah, they're using standard units because they've not converted anything there. Yeah. So we've got the cross-sectional area of the ship at the bottom. So we can say that the mass of the ethanol that's being displaced is equal to 920, which is the density, multiplied by the volume, which is 20,000. Oops. 20,000 times H, right? So I've just subbed in that 20,000 into that A there and put that into this bit here. Okay, so, and we also know that because these G's are going to cancel out, that's going to be equal to the mass of the ship. So the mass of the ethanol that has been displaced is going to be equal to the mass of the ship because they're going to balance one another out. So the mass of the ship, I believe we presumably have from the example. Well, okay, it must be somewhere anyway, but it might be in another part of the book. Shall we just get the book out to have a look? Okay, so the mass of the ship, from looking at a different part of the book, tells us it's 400 million tons. So that means that, so let's just rewrite this now here. We've got 920, just close that, times 20,000 times H is equal to, was it 4? Oh, I've got it again now. It's 400 million. So let's just say 4 times 10 to the power of 6, 8. Yes, 8. Okay. And it's 8 is what we're trying to work out, remember? So we would just simply rearrange this at this point. I got a bad feeling I've made a mistake at some point here, but we'll carry on for now and we'll see. We'll check it in a moment. Right. So that's what I've got. Well, before we go to the effort of tapping that into our calculator, shall we just go backtrack and see if we've done everything right? Did you follow it, do you think, as I went through? So we said that the mass of the ethanol must be equal to the mass of the ship because these two must balance and the G's cancel out. So the mass of the ethanol that has been displaced must be equal to 4 times 10 to the 8 kilograms because that is the mass of the ship. We then said, well, the mass of the ethanol is also equal to density times the volume of the ethanol, density of the ethanol times by the volume of the ethanol. So density of ethanol is 920, standard SI units, and the volume is going to be worked out by the cross-sectional area of the ship multiplied by the height, and the height is the thing we're trying to find out. So that volume multiplied by the density is going to be equal to the mass of the ship. So maybe we can say this, that the area, or the cross-sectional area of the ship multiplied by H is going to be equal to multiplied by the density of ethanol is going to be equal to the mass of ethanol, which is 4 times 10 to the power of 8 kilograms. Okay, and then we can say, well, we know that means we can rearrange this to say height is going to be equal to the mass of the ethanol, or the mass of the ship, if you like, divided by the density of ethanol multiplied by the cross-sectional area of the ship. Yeah, and that's it, because height is left over there. So yeah, this is all what we've got here. So I'm fairly confident I've done this right. If I have done something wrong, I've not spotted it. So then we just put that into a calculator and see if we get it right. So apparently 46.6 meters. Now we can actually check to see whether or not that looks about right. We're gonna, because we did in the example did show the height it was under the water, and because ethanol's less dense than water, we would expect it to sink further than that. So hopefully 46.6 is greater number than the number underwater. Oh, that looks good. So yeah, that's good. And in fact, it's probably going to be a linear relationship. Is it? I think. Not sure. Maybe. So 19.4 is the height it would sink in water. So and what's the density of water? The density of water is 1,030, and the density of ethanol is 789. Okay, yeah, good. So actually, that looks about right. Say again, sorry.